Today's lesson will cover angles of elevation and depression. Let's start with angle of elevation. And let me start first of all that you're going to see badly drawn pictures today. Okay, thank gosh Mr. Roeder's a math teacher, not an artist. So in this scenario here, I have a squirrel looking up at an eagle. So the angle of elevation is defined as the angle formed by the line of sight and the horizontal plane for an object that is above the horizontal. So the horizontal is down here. Okay, so the squirrel normal eyesight would be straight across, parallel to the ground. And then the squirrel looks up. So this right here is the line of sight. Okay? So the angle of elevation goes from the horizontal up to the line of sight. So this is the angle of elevation from the horizontal and up. Okay? Now, angle of depression. The angle of depression is the angle formed between the horizontal and the line of sight to an object beneath the horizontal. Now we have an issue here. I haven't drawn the horizontal yet. So imagine here's you looking down at a rat. Okay, the horizontal is straight across, parallel to the ground. Okay, so this is the horizontal. And when I do these problems, I want you guys to know that this is like when you have your eye level. Okay, so that's what I'm doing. When I walk, I'm looking straight ahead as I walk, and that's parallel to the ground. So eye level. Okay, line of sight right here. Okay, we notice the rat on the ground. It's a line of sight. Okay, and so the angle of depression goes from the horizontal and down to that line of sight. So it's this angle here. Okay, a lot of people think that this is the angle of depression, but you remember you got to start with your eye level. Okay, straight across and then look down. It's not the I'm already looking down and then down to my toes angle. Okay, it's not called the angle of looking down and down again. Okay, horizontal and here. All right. Now, one thing I said, if you caught it, I said that the eye level is parallel to the ground. Well, you might be like, wait a second, ground and eye level parallel, and this is a transversal? That means that I have alternate tier angles. So this angle of depression is equal to the angle right here by the rat. Oh, guess what that angle is? That's our angle of elevation. Okay, so something to think about. The angle of depression is congruent to the angle of elevation. Okay, and that is going to be useful when we solve problems. Alright, let's start with a scenario here. Okay, first scenario. So we have Jill put a ladder up against the house to try and reach a light that is out and needs to be changed. She knows that the ladder is 10 feet long and the distance from the base of the house to the bottom of the ladder is 4 feet. Okay, what angle is being made between the ladder and the ground? Okay, so here is my house. You can take a moment and draw the house yourself. I've got my house and I've got the ladder. I think Jill has issues with putting the ladder up against the house, but whatever. Okay, so since we're going to be using trigonometry to solve this, remember that we have to have a right triangle. So when you illustrate your picture, make sure you include a right angle in that right triangle that we have right here. Okay, so the ladder and the house are making a right triangle. Okay, so details they gave us. The ladder is 10 feet long, and the distance from the base of the house to the bottom of the ladder is 4 feet. And they asked us to solve for the angle being made between the ladder and the ground. So I'm going to call that A. A lot of people like to use X, but I figured let's use something more contextual, and since we're solving for the angle. Okay, so using sine, cosine, tangent, this is the angle, reference angle. I'm given the adjacent leg and the hypotenuse, so we are going to use cosine. So, cosine of that angle is equal to 4 over 10. Okay, we do the inverse because we're solving for an angle. So we get A equals the inverse cosine of 4/10. And then A is approximately 66.42 degrees. Okay, number 2. You are a pilot of an airplane that is flying at an altitude of 3,000 meters when the plane begins its descent towards the ground. The angle of descent of the plane is 15 degrees. So how much further will the plane fly before it is on the ground? Okay, so here is my plane and the ground. Okay, so some details we know. Okay, so I know that the plane is at an altitude, a height of 3,000 meters. So we have 3,000 meters is the height. And we got the plane descending. So I think you guys can agree that the plane is descending like this, if this was its like a path where it was flying down. Now the angle of descent is 15 degrees. Okay, so we got to decide angle of descent. Okay, so I'm going to give you guys 2 scenarios here to solve this problem, and one way is right and one way is wrong. Okay, so you got the plane at 3,000 feet. Now some people, if I were to draw this accurately at 15 degrees, some people will draw the angle 15 degrees like right in here. Okay, so they've got the plane's path going this way, and then they'll put the 15 degrees here. Let's see if that really makes sense. Okay, so 15 degrees, if I were to measure that with my protractor, would be an angle that goes this steep. Okay, so not even that. Could you imagine a plane just going down that way? I think you just killed everyone in the plane. Okay, so labeling this 15 degrees is not the angle of descent. Okay, on the other hand, okay, and the misconception here was we forgot about how the plane is flying horizontal parallel to the ground. Okay, so let's go with that this time. So I know that the plane is flying parallel to the ground. Okay, and then it begins its descent. If I use my protractor and measure, the angle of descent would be something more like this. Okay, so from here to here. Okay, so from the horizontal and then down. That seems like a more appropriate angle of descent and not some plane going down this way. The actual angle of descent in this wrong way would have been 75 degrees. Okay, that's 15, that's 75. These would be complements making a right angle. Okay, so be really careful. Does the story make sense? Okay, so in this one here, so our angle of descent, remember, is made between the horizontal, where the plane originally was going in this direction, parallel to the ground, and the angle of descent is 15 degrees from the horizontal down. Okay, and you could say down to the object, maybe the airport where the plane is going to land at. Okay, so we got 3,000 meters, I got 15 degrees. Now the 15 is not inside of the triangle, so I'm going to use the idea of alternate interior and put the 15 degrees in here. Now, hopefully you're saying, Mr. Roeder, you're missing something in your triangle. And you're like, you're right, I forgot the right angle. Okay, so make sure you put the right angle in there. Okay, so let's see. Now the question's asking, how much farther will the plane fly before it's on the ground? Now this one, some people will give me 2 different answers. Are they asking how far the plane is directly to the airport, or how far is the plane flying until it gets to the airport or the object? Okay, if you've ever flown a plane and you look at the screen, if your seat has a screen, and they show you that the plane still has another 200 miles to go, they're talking about the horizontal distance here. Okay, so that's the context. Some people would solve for this, and I would accept both answers only because some students don't quite know the difference or like really understanding what they mean plane-wise. So when we're asking in a plane how far is the plane until it lands, we're talking really this horizontal distance. Okay, not a big deal. Okay, so we've got the angle. This is our reference angle. Across from it, opposite side, and the adjacent side. Okay, so therefore we're going to be using tangent. Okay, so tangent of 15 degrees is 3,000 over d. Okay, multiply both sides by d. So d times tangent 15 degrees is 3,000. d equals 3,000 over tangent 15 degrees. And so d should be approximately 11,196.15 meters. Okay, last example here. Abby is standing at the top of a very tall skyscraper and looking through a telescope at the scenery all around her. The angle of decline on the telescope says 35 degrees. Okay, so the angle of decline, 35 degrees. And Abby knows that she is 30 floors up and each floor is 15 feet tall. Okay, they've asked us two questions here. Let's answer the first one here. How far from the base of the building is the object that Abby is looking at? Now the problem's a little vague. We're going to assume that the object's on the ground. Okay, so here's my picture. We've got the building, got Abby looking out at a telescope. Here she's looking down at the object. Okay, now we've got some facts here. Abby knows that she's 30 floors up and each floor is 15 feet tall. So if you did your math, hopefully you realize that that's 450 feet. Okay, how far from the base of the building is the object? So let's label that D for distance. Okay, and we have the angle of decline says 35 degrees. Now once again, her original eye level was straight across this way. Okay, the horizontal, the eye level, it's parallel to the ground. And so sometimes they're not going to say angle of elevation or depression. You got to use the clues to think about what it is. And so they said decline. Okay, so hopefully that seems obvious to you that we're talking about the angle of depression. So 35 degrees. We're going to use alternate interior angle theorem. Label the angle in here. Okay, and let's solve for the distance here, now that I know an angle and one of the sides. Aha, but I forgot something. Remember to label the right angle in your picture. Okay, if we're going to use trigonometry, we got to have a right triangle in these problems that we're solving. Okay, so I've got my reference angle. I have my opposite leg and adjacent leg, so we're going to use tangent. So tangent of 35 degrees is equal to 450 divided by D. And multiplied by D. So D times tangent 35 degrees is 450. Divide by D, we get 450 divided by tangent of 35 degrees. And so D will be approximately 642.67 feet. Okay, last question here. How long is your direct line of sight to the object? So they're asking for how long this is. Okay, so let's label it L for line of sight. Okay, now I know two sides of the right triangle, so we could use Pythagorean theorem, but the problem is that's an approximate answer. We could be more exact. Let's use trig again. I know the reference angle, I know the opposite leg, and we're solving for the hypotenuse. So if I know the opposite leg and hypotenuse, I'm going to use sine. So sine of 35 degrees equals 450 divided by L. Multiply both sides by L, so sine of L times sine 35 degrees is 450. L equals 450 divided by sine of 35 degrees. Remember that I'm always writing the exact answer. If I didn't have a calculator, I know I can at least stop there. And then L is approximately 784.55 feet. All right, there is your application problems dealing with angle of elevation and angle of depression.